final section of the sample test starts with a u substitution problem with definite limits. So I start out by identifying what u is. In this case, u equals 5x minus 2. I take the derivative of both sides. On the left, I get du. On the right, I get 5 dx. So I now need to rearrange this so that I have 5 dx under the integral. In order to do that, I need a 1/5 out front. So it's going to become 1/5 the integral from 1 to 3 of 5x minus 2 to the negative 1/2 times 5 dx. That means I can change everything to u's by now making it 1/5 the integral from 1 to 3 of u to the negative 1/2 du. That's going to integrate to 1/5 times u to the 1/2 divided by 1/2, evaluated from 1 to 3, which really, when I multiply by 2 over 1, is going to become 2/5 the root of 5x minus 2, evaluated from 1 to 3. When I put in a 1, that's going to give me, when I put in a 3, that's going to give me 2/5 times the root of 3 times 5 is 15, minus 2 equals 13. From that, I'm going to subtract 2/5. When I put in a 1, I get 5 times 1 is 5, minus 2 is 3, so root of 3. I don't know how to do these in my head, and I think I'd rather clean this up and get a decimal answer. So I'm going to start out 2 divided by 5, multiply that by the root of 13. Then I'm going to subtract 2 divided by 5 times the root of 3. When I put that all in, my calculator tells me my final answer is 0.749 if I'm rounding to 3 decimal places. Just make sure you're careful to follow whatever instructions they give. This asks me to find the derivative in number 15 of y equals 7x cubed times the ln of 7x. First thing I should see is that this is being multiplied function of x by another function of x, which means I need to use my product rule. So when I go to find the derivative, I'm going to rewrite the first. I'm going to multiply it by the derivative of the second. When I go to take the ln of 7x as derivative, I see it's a chain rule. Basically, whenever I have ln of something, the end result is 1 over that something times its derivative. So it becomes 1 over 7x times the derivative of 7x, which is 7. I add to that second times derivative of first, ln 7x, times derivative of first, 3 comes down, 21x to the second. Cleaning this up a little, this 7 on top and this 7 on bottom are going to cancel. So it just becomes 7x cubed divided by x, which is 7x squared. Here I can only take the 21x squared to the front, and I have to leave the ln of 7x. For number 16, it asks me to integrate 11 over x dx. Really, that's the same thing as the constant 11 times the integral of 1 over x dx. We know what the integral of 1 over x dx is. It's ln of the absolute value of x plus c. So this just becomes 11, the ln of the absolute value of x plus c. Final problem asks me to use my knowledge of the exponential function to find the derivative here. Remember that the derivative d dx of e to the x equals itself e to the x. At any point, the slope of the exponential function is its y value. So when I look across here, I'm going to have to do a couple product rules. First one, finding the derivative, I'm going to do first 2x squared times derivative of second. Derivative of e to the x is still e to the x. Then I'm going to add to that second, which is e to the x, times derivative of first. 2 comes down, and I get 4x. Plus, when I get to this next term, I'm going to do first negative 4x times derivative of second, e to the x, plus second, e to the x, times derivative of first, negative 4. Finally, when I get to 7 e to the x, its derivative is just itself, 7 e to the x. Cleaning this up a little, y prime equals 2x squared e to the x. Here I have a positive 4e to the x. Here I have negative 4x e to the x. Sorry, positive 4x e to the x, negative 4x e to the x. Together, they equal 0. Here I have negative 4e to the x. Here I have positive 7e to the x. 7 minus 4 leaves me with 3e to the x. So this would be my correct final answer.